Hello, my name is James Black, and today I'm going to be talking about how to decompose PetClinic, which is a project by Spring to go through how to use various renditions of Spring. So we're going to be actually talking about how to turn it into reactive microservices. So let's start with looking at, this is a basic architecture of the application. So we have largely 4 controllers for visit, owner, pet, and the vet. And then they go to they each go to databases. So 4 controllers, 4 databases. Pretty typical monolithic application. So there isn't, the clinic service is just a abstraction to show how these different pieces are tied together. And then I decided to, for some of the services, to actually create a sequence diagram. And they all basically follow the same pattern, where you do a post, like in order to add a pet, you first have to get the owner ID, which means you have to go to the owner repository, which goes to the MySQL database, and then that actually will send back, forgot that part, the owner ID, and then you'll actually save the pet. So save a pet is 2 calls to the database. And then if you want to update the pet, you just largely just end up going controller, repository, database. So they all follow this pattern, and then they redirect. One of the things that this application does, which is problematic, is they don't actually return back any errors. So if I had an error while I was trying to insert a pet, I'd still be redirected back to this URL. The functions return a void. So, and then any exceptions that are thrown will go to a one exception handler. So there's really no way for the user's just told, here's the exception, and they might see a stack trace or whatever the exception handler does. But there's really, in terms of a user experience, this is probably not the best choice. But this is what a lot of people did. And one of the problems I have with how we do examples is when you don't even put in a comment about how there should be error checking in here, then people will follow these patterns and say, well, this is the way that they expect us to do it. And they don't really understand what's going on. So they will just follow this pattern, and this becomes baked into a lot of applications, which is why we end up with a lot of security problems. And then we also have bad experience problems because people didn't look at what is this the best choice for how to do tasks. So for example, up here, one of my problems with having the controllers at the first is if I've had situations where I've had to use soap and rest, and I wanted to go to the same controller so that way everything else could be identical. But I didn't want to have a visit controller that's rest and a visit controller that's soap. So what I ended up doing, I ended up creating a different abstraction that sits before both of them, and that would actually have the endpoints. And then it would just do the marching on marching that was needed, and then use the controller, and everything else is identical. So that way it simplified my testing. Because I could just test the controller on down. I didn't have to, and then the endpoints I could just test separately, and it all worked fine. So unfortunately, too many people have it baked into their mind that you have to have the controller first, and that's really based on situation. So we need to look at why we have the architecture we do. Okay, so then we have what is a reactive application really? So I'm going to try and keep it simple. You can watch lots of videos on reactive. This is in response to my first video where I go into more in depth about reactive. So it's actually, I'm talking about reactive architectures. And a user doesn't care about excuses. They bring up your mobile app, they go to your web page, they expect to see the data when they need it. It should feel to them to be responsive. If they have to wait, if you click save and it takes 5 minutes, they're not going to be real happy because that's not responsive to them. That's sluggish. So at the end of the day, everything about these reactive architectures is we want things to be responsive. Okay, but we have different situations. So for example, what if there's failures? Database goes down, you had a router go out, you had a data center go down, you had a hard drive fail, you had an out of memory exception because perhaps some of your memory chips have failed. Lots of things can go wrong. That's just life. Your system should be able to self-heal. So when you correct it, when a new database comes up, when some action happens to fix the failure, your application should respond appropriately so that way everything can go back to being responsive. So this is resilience. Basically, it's kind of like that punching thing where you punch the weighted dummy, it goes back, it comes back up. You want to make certain that no matter how many times your application is knocked down, it will come back and as it was before. Okay, so we also have problems with underload. If with most monoliths, if I have a lot of connections coming in, I'm going to, because I have so many threads running, I'm going to start to have the entire application become slow. Especially in Java, you'll start doing lots of garbage collection. And so that will slow down the entire application. I've seen applications slow down for like 7 seconds at a time due to garbage collection. So you want to make certain that you are using no more resources than you need. You want to be cost efficient because a lot of times these are in the cloud. And you want to be friendly to the environment because you don't own the environment. You are borrowing it. So this is elasticity. So you should be able to scale up and scale down based on demand, because scale up is to keep everything responsive. Scale down is to be resource efficient. So this is important that your application be able to handle that type of situation. And at the end of the day, this all means that it has to be message driven. You can't just use client server for all this because in part, if you're making a client connection, you're coupling. I know that I call this IP address or this host name and on this port with this command and with these parameters and something's going to happen. What happens if I move that? If I move the server, then I have to fix my application. So you want to have where we don't even want to know necessarily where the services actually are. So you'll end up using messages. So we'll know where the gateway is, and the application will know about the message broker, and that's about it. So let's look at some failure cases first. So we could have I talked about some of these, but you could have a database slow. So if someone did a bad query, and remember a lot of these databases are shared, so I do a table scan I do a scan select that does a table scan over millions of rows, it could get slow. So that will slow down all the applications that are using it. The database got moved. So I had a backup site. The main database went down. I switched to the backup site. Probably have to switch my configuration, or I could hopefully you set it up with a CNAME, and then it's kind of like a redirect for DNS, and then you just have to. But there's a small delay while you have to try and tell the servers that the address has changed. You could have an out of memory exception, and then the user will see an error message because your web server can't really do much without memory. Sudden increase in clients. So you had a commercial during a popular TV show, and all of a sudden a lot of people start hitting your site. This relies on the load balancer to know what's going on. Problem with this is if you try and spin up a bunch of new like JBoss servers, for example, then it's going to take time because they're big, and then the load balancer can do all the round robin things to try and help spread out their work, but for a period of time, people were getting errors back because it was more manual. Even if you're using AWS and you're doing load balancing through them, it can take minutes to start up a new EC2 instance. So that becomes a problem. And the servers could just become slow. So, okay. So with microservices, there's different aspects we have to contend with. So a monolith has all of this. That's why it's a monolith. Built in as one application. So we'll start with the gateway, just because that's the very first thing you see. So in the communication area, you pretty much have to have a gateway. You have to have some servers that you know, okay, this is the starting point of my application on the back end. That's the only thing you have to really know. You have to deal with different options on deployment. So do you want to have a service per container, which is what I tend to do? Do you want to have multiple services per host? This is, if you're not necessarily, you may not be using Docker, and so you might have, let's say, an EC2 instance, and you may want to just have multiple services running there. Even though it might be lots of different Spring Boot instances, for example. You could have a single service per host, service per virtual machine. So different options on deployment, but these all have to be dealt with. You have, how are you going to be doing discovery? So is the client doing it? Is the server doing it? You have to figure out about your service registry. How do you register? Especially third-party servers. So you know that there's you're a weather application, and so you're going to go to the weather site. How are you going to get them? How are they going to register so that you know where they are? So we have different issues that have to be dealt with when going to a microservice. So what I tend to do is I tend to start grouping my web services into domains. And a domain is basically just a self-contained object. So for example, my pet stuff all goes into one domain. If I'm doing a shopping application, I might have my order might be a domain. An order has a group of products, but they actually just have the product ID and perhaps the price. Generally just product ID. I would have to go get the prices from the later, but the order stuff, your cart, is the data structures used for these domains. They'll have several different data structures, and they will all be related. So they should. You want to try and limit how many if shared data structures. So in this case, for example, I'll have 3. There's actually 4, but running out of space, so I just went with pet, visit, and owner. And then I put the web services underneath there. So you have get, create, and edit. But we only have one MySQL database. So we have 3 controllers that call the repository to one server. So if this server goes down, all of these are down. If this is slow, all of these are slow. That's the real problem. That's why I like to use sequence diagrams, because by doing this, then I could say, I could do what if. Well, what if this is slow? What's everything that's going to be impacted? And as you start to split up your application, then you change your sequence diagrams, and then you continue to do the what if game to make certain that you're fixing the problems and staying, because at all times you want to make certain you're staying reactive. The goal is responsive in all situations. So now, once we've split up our work in our web services into domains, now we're going to have to organize based on our database needs. So what I like to do is, and this depends on each use case, but in this case, you're going to have fewer pets created and updated than you're going to be getting. I'm going to be making far more appointments or looking at my pets than I'm going to be getting new pets. So it makes sense to have one web service that goes to a MySQL database that does that's writable, and then all the get web services will be going to a cache. And so this is obviously just read-only. So we're now starting to split our application up into different aspects. Now you have to look at deployment. So we go back to that earlier slide about different options of deployment. I like Docker. So if it works for the needs, and again, it depends on, are you using AWS, are you using Azure, Google, or are you using one of the open source like OpenShift, or Cloud Foundry? I mean, what will work best with the cloud provider you have? So, but in this case, what I like to do is try and keep in my mind that each web service, each microservice, so this microservice has an embedded HTTP server. First time I saw this was actually with Scala. I was using a library called Scalatra, I believe it was, and it would embed Jetty. And I like that because then it didn't even know how to serve up a static page until I told it to. So these things only know how to do what you tell them to do. So there is a much smaller attack vector because they're not like JBoss or IIS where you have so much intelligence that you could perhaps get it to do something that you didn't want it to do. So I like the idea of using these embedded servers in applications. So plus they have a smaller footprint than these more general web servers. So I would just group both of these into their own little Docker containers. So that way, if I get a sudden load increase, I can just spin up new Docker instances for get, and I can handle the load. because they will all have the same cache as the data that's in the MySQL database. We'll look at that later. And everything is good. And then once the demand goes down, we start taking down these containers. They'll unregister themselves from the discovery server, and then we will, the system maintains being usable. So we basically have this idea of when you're deploying in a monolith, you would have lots of app servers, like you have lots of JBoss servers, and you would have a cluster of databases over here. So you'd have your load balancer, would know about all these, but then we go back to, well, what happens if some of these go down? Or what if this is slow? The load balancer can't really do much about it. It's still going to be sending some people to a slow system. These are hard to troubleshoot because then you find that most of your users are having a reasonable experience. Some are having it be really slow. In my experience, it's hard to tell to troubleshoot when one server is slow. The only thing you really do is start taking different ones out of the load balancer until the problem goes away, and then you say, okay, that one's bad. That's hard. So we also have, with a microservice, you end up having a service discovery. You have some sort of monitoring because you have a lot of different moving pieces now. You need to make certain what's going on. So it helps to have a lot of, to have automated your monitoring. You have some sort of configuration management. And then you have all of these different microservices, all of these different kind of setups like this here, okay? So we might have, like, the dark blue is all one container, so we have 2 instances of those, one of the green, 2 of the yellow, things like that. So deployment is very critical to consider. How are you going to do this? And the problem is that there's different options. So there is no one way to do this. Okay, so I've been talking about service discovery. Service discovery is kind of like a Yellow Pages or an operator. You are going to contact the operator and say, I need a plumber. The operator is going to say house or residential. You say house. They will then give you a phone number. Okay. So same thing with service discovery. You say, this is what I'm looking for, and it will come back and say, okay, here's a service that can meet your needs. Which means that every time your microservice starts up and shuts down, it's going to need to register and unregister with the service. So it may not be on startup that it's going to register. It may be once the database is all set up. So at some point, you need to tell the service, I'm ready. And then when you're not available, you need to say, yeah, it's lunchtime. I'm not available, so I'm going to deregister. So this is critical. And there's different ways you could do this. So, some toolkits will have their own service discovery built into it, and some you'll need to use an external application to do that. So we were talking a bit already about gatekeepers. The clients won't know the address of the microservices because they keep going up and down. So it's hard to keep track of them. You may want to make changes to your. So right now I've been using REST for this between the Gatekeeper and Pet. What if I want to change it to use MQTT? If I want to change it to use RPC? I want to split this up into 2 different microservices. I should be able to do that without affecting the client. Because again, the client doesn't care what is past the gatekeeper. They just know they have a certain function they want done. They just want it done. But you also have other functionality that the gatekeeper has to do. It has to take care of authentication. Failure handling. So if something is really slow, for example, it should be able to time out and tell the user that either tell a user or time out and make another call to a different microservice because there might be a problem with the one that it was using. It's going to do a very simple load balancing because it actually got, it may have been told there's 10 different services that can do the task they want to do. It uses one, it moves on. So the gatekeepers kind of important, and again, we go back to some toolkits will allow you to, it'll be easy, it'll be built into the application, the ease of doing this, and some will be where you'll need to use external applications. So lots of different options there. Now we go to databases. If you have any read-only databases, you need to keep them up to date. This is pretty important. So there's going to be different discussions as to, do I want to use a shared database, which again we go back to, you have all these microservices going to a cluster, or do I need to have a private database? So you may have a database per server. So how do you want to do this? And the problem is that there's a lot of different types of databases. You have NoSQL, you have NewSQL, you have RDBMS. Even in NoSQL, there's different types. So you end up using Brewer's theorem to look at, do I want consistent, partitionable, or available, CAP, to help determine what the requirements are. So this will be really based on the domain and on each web service itself. What are the requirements? This is probably one of the biggest changes, is you actually need to have better requirements for every service. It used to be that we got some fairly vague requirements, and then you wrote your web service in your monolith. Now you need a lot more detail because, for example, how slow is too slow, and what happens if something's going to take a long time. So, for example, if I have to go to a legacy system, I have to go to the mainframe through data power. Well, that's going to be slower than going to my own local MySQL database. So how do I do that? How is too slow going to be if it takes more than a second? 500 milliseconds? I may not actually want to stop going to the mainframe. I may want to allow it to happen and have it, when it comes back, update my database and just tell the user. But we have to have this information. We have to know what are the requirements. And this is probably one of the, this is going to be a critical part. You need better stories at this point. When you start up your new instance, you created a new microservice, spun it up. Your database may be empty, it may be in an old state, so you want to make certain it's synced up before you register and say, I'm ready for service, because you're actually not ready for service because the database isn't complete. Publish subscribe is a good approach. Kafka uses this. Do you want to have some sort of a way to where when I write to the pet database, that I then send a message onto a message bus, and then all of the get microservices for pet would get that data and update their cache. Because there's this delay, these end up being eventually consistent, which means that eventually, if everything settles down, they'll all have the same data. But at any given time, some of them will have some data that others don't. When you're in a distributed fashion, you can't really do much about that. So then we have um, trying to get out of the light a bit. That's not any better. So then we have I need to send my data. I don't want to send a SQL query because I may have a different type of database. I may have I might be using an Aurora database, for example, if I'm on AWS for my writable, but I might be using Elasticsearch for my cache data, or DynamoDB or something else. Cassandra, doesn't really matter what's in the cache, but it's not going to be the same database. So SQL queries don't really make sense. So what do I want? How am I going to be? Am I just going to be sending events? So, and then how do I prevent the event bus that's being used to keep everything synced up from going down? So these are all different questions that have to be worked out. So how do components talk to each other? You saw from before that if I want to add a pet, I have to go get information from the owner. Well, about the owner. So how can I just can the pet just directly call the owner, which means that I might be using a Rust call. So I may have to use service discovery to find out, give me an owner, and then so I can go get it. Or is there going to be a message bus of some sort, an event bus, so I can just put a message on there and some owner will pick it up and return to me the data. So this has to be worked out as to how this will all actually work. These all actually end up having all this data, all this information, decisions have to go to an architectural document. So that way someone can understand what were these design decisions and why did you make them. It's really important to put down why. Because later someone will say, well, it would have been better if you had done this, and then you could have put it in. I tried this option, it didn't work for this reason, so don't do this. I've actually made comments in code before where I said, don't uncomment this block. I tried it and it created this problem because you might think it's a better choice and then it ends up causing other problems later. Okay, so then we have our communication protocols. Do we always want to pass JSON? JSON is really good for going to the browser. For JavaScript, it's its native marshalling on marshalling format. So it's really fast. For Android, iOS, it's slower. It's big. It tends to be much more bloated. And it takes more time to process. Because you have to parse the entire object. You have to create the new classes from it. You could use remote procedure calls. Very old school, but using protobuf from Google as a binary format, you can use gRPC, and then that can make it much faster. So, for example, I like the idea of using gRPC from the gatekeeper down. But again, that then means that every time you make a change to a interface, that you have to create the new stubs, everything has to be recompiled. So there's extra work involved there. There's a trade-off. Do you want to use MQTT for if you were sending lots of little small packages? MQTT is a pub/sub protocol. You can use HTTP too, which I recommend. That way you can get streaming. It's faster. There's a lot of benefits to HTTP too, and all the browsers support it. So, but these all have to be documented. Okay, then you have debugging. Things happen. User calls up and says, I was trying to do this, it was slow, I got the wrong data, whatever. You need to be able to figure out what's going on. So this is where we get into events. Events are, I could save the, I could look in the access log and say, okay, you made a get, you made a post, and but I can't take that data and rerun it in a separate system and see if I get the same experience. So I'd have to ask you, okay, well, can you tell me exactly what you did? If you save the events, then what you're doing is you're saying, the person, they went to update a pet with this information, but you're not necessarily saying they called, that they made a post call, for example, because it doesn't matter. That's not part of the event. That's the command. So in some cases, you'll want to save commands. You'll want to save, in other situations, you'll want to save the events. The data sent between that updates the cache from the MySQL database is an event. So you'll want to save that. One advantage of saving events, by the way, for a database, you only want to save state changes. So you want to save any deletes, updates, inserts. So that way, later, if you needed to, you could rerun all of them and get the database back to the state it was originally. But at that point, you don't care about the gets because they're not changing any state. So up here at the gatekeeper, or in the communication between the controllers, you may want to keep track of all the different events. So you'll want to know about the gets. So that way, when someone asks, well, how often what percentage of gets do we do as opposed to updates? You can pull that information out of the event store, and you can look at the event log, and you can look at the actual numbers. So that's beneficial. But you also want to save information about how long you spend in each stage, though. So if I have multiple points, I call from my web service, I'm calling a different web service that then goes to data power, that goes to mainframe. As much as possible, I want to be able to know how long I spent in each stage. So, and then you can save that as part with the event as metadata. And then that way later you could look at, well, is this slow and how slow is it really? So it will help with optimizations. Okay, then we get into the big thing about testing. Testing a asynchronous system is harder, much harder. Mainly because I can't just make a call and then go, I did an insert, immediately just turn around and get the data, and I can compare them. I can't do that necessarily because, again, we have eventual consistency. So you could look at, well, how long does it take for things to get updated, and then I can have it delay, and then I can do, but again, that goes back to if you were saving the information as to how long does it take for all these little caches to get up to date. So you write your unit test. That's just plain old Pojo or whatever, just basic unit tests. Then I tend to group my integration tests. The only reason for the integration test is to pretend I'm a client. And a lot of times I use them so that when people ask, well, how do I call your service? Well, just go look at my integration tests and you can see. That way they don't keep on asking me because there's an example. Acceptance tests are not as common. A lot of QA groups still use Postman or SoapUI, for example, and they do it very manually. So we need to automate this puppy. So you can use, there's different ideas, but I like BDD, behavioral driven design. So you can just do it's largely a when in this context, or given this context, when this event happens, then do this. Or then this should be a result. So you are so you have the context, or you have a setup, kind of. You have the what took place, and then you want the output, and then you automate it. So that way it's automatable, and you can use Cucumber to help with this, and that way you're able to test. I don't test all options between all your services. You might have 30 different microservices. You don't want to test every permutation between them. Find out what are the expectations. Get the acceptance criteria, just test those. You may find out later that there's a different use case that's going to come up that might have a bug. We're not trying to solve all the possible bugs. We just want to make sure that what we have done for our users is bug-free. If someone else comes up with, hey, here's a completely different idea, that if we call these different services and we jump between these different points, you may find that there was some inconsistency between them. Don't worry about those. Try and be more agile in your approach, and just try and do what's needed for the users. So a lot of times I'll let the client, for example, all the clients, they will help to drive the acceptance test. And that's basically, if you're at this point, then you are most of the way to having decomposed your application. And along the way, you constantly ask yourself, is it resilient? Does it support elasticity? And is it always responsive? Always ask yourself those questions in every decision you make. So when you're sitting down with someone saying, okay, here's my architecture that I'm doing for this part, they could ask those questions and you can explain how that is indeed still true. And that's it. I'll make another video to go into more detail later about how to do this, but this should at least get you started with trying to decompose. One thing you don't want to do, I'm not a big fan of, you need to make certain not to have don't have too many layers. So you'll notice I didn't have a separate web service just to write to the database. So it would go to this database. You don't want to have too many layers, because then it gets to be overly complicated. The more moving parts you have, the more things that can fail. So I like the KISS principle, but keep it silly, keep it simple. So that's critical also. And that should be about it. So have a wonderful day. Bye.